All right, here's a quick review of the periodic table and all that we've learned in chemistry to this point. I'm going to try to move very quickly. If you need to use the pause button, do so often and take notes as you need. The periodic table, matter and energy, this is the TEAC. The matter and energy, the student knows that matter is composed of atoms and has chemical and physical properties. The student is expected to describe the structure of atoms, including the masses, electrical charges, and locations of protons and neutrons in the nucleus and electrons in the electron cloud. We covered that in the very beginning of the PBL in the first student journal, if you want to refer back to that. Also, identify that protons determine an element's identity and valence electrons determine its chemical properties, including reactivity. That we talked about in the second one, protons and reactivity, the second student journal. And what we're going to focus on mostly today is interpreting the arrangement of the periodic table, including groups and periods, to explain how properties are used to classify elements. The periodic table. Where are some places you have visited that have areas or items organized into categories? We are fascinated as human beings with grouping like things together, and the periodic table does the same thing with all of the elements. Come up with a list of 10 items. Come up with your own system for organizing or categorizing these items. Use construction paper to create a table. If you feel like this will help you in studying, you can follow these instructions and do this. But for the purposes of the review, we may not want to do all of these steps. You do want to be able to explain the system, a system for organizing things. And we talked about it in class today, why the periodic table is organized the way it is. That groups share similar properties. The group 1A shares similar properties because they all have the same number of valence electrons, and everything in the same period or row going horizontally across, the number of the row or period tells you how many energy levels are in each element. The periodic table is organized with a system for classifying all of the elements. Elements are made of atoms. Here's a model. This is called a Bohr model of an atom. The blue plus signs are our protons, so this would have an atomic number of 4. There are 5 neutrons in the nucleus, and then you see there are 6 electrons. What are atoms? They're a unit of matter, which is the smallest amount of an element that exists. An atom is made up of protons, neutrons, and electrons. The protons are found in the nucleus. They have a positive charge. Protons have a mass of 1 AMU. Neutrons are found in the nucleus. They have a neutral charge. They have a mass of 1 AMU. They only contribute one thing, not a charge to the atom, but contribute to the mass of the atom. The mass of the atom is the sum of protons and neutrons. Electrons move in an electron cloud or energy level around the nucleus. Now we talk about it as an electron cloud because you can't put your finger on where an electron is. They're moving very quickly. But we do know that they're organized into levels. The first energy level holding 2 electrons, and every energy level after that holding 8. They are negatively charged, and their mass is negligible. They're 2,000 times less massive than protons and neutrons. So electrons are much smaller than protons and neutrons, less massive, I think is a better way to say that. How many electrons can fit in the first energy level of an atom? 2. The second energy level? 8. Third energy level? 8, and every energy level after that. The Bohr model is what I just explained. That's the models of the atoms we were just looking at with the nucleus in the middle and energy levels around. They're a simple model that depict the number and locations of the protons, neutrons, and electrons. We can organize the Bohr model cards into groups. This is another activity that you might find useful. Feel free to do this if you think it'd be helpful, but for the purposes of studying, it may not be the best use of your time. If we made a model of each atom, we could organize them, and you would find that the pattern repeats, and you would end up recreating the periodic table based on the number of energy levels and the number of valence electrons. Why is it called the periodic table? The repeating pattern is called a periodic property or trend, which is how the periodic table of elements got its name. Newspapers and magazines that come out monthly are called periodicals because they come out at regular intervals. So periodic means a regular repeating pattern. The properties repeat themselves. That makes sense. If we're looking at the groups, we see that everything in the same group has the same properties because of their valence electrons, and that these properties repeat themselves as the pattern goes on. Periodic properties help to predict the property of the next element in a group or period. Can you think of any other repeating periodic patterns that occur in nature? You probably can think of several, and if you need these associations to help you, there are lots of repeated patterns. I'll show you an example in a minute. Seasons is one. Spring, summer, fall, winter always occur in that order. It's a periodic pattern. And moon phases always occur in that order. Definite repeating periodic pattern. Also, the tides are recur in a periodic pattern. Day and night always in the same pattern. We study this a lot in science. We're fascinated with organizing things and with finding patterns that repeat. It helps us to understand the world around us. Periodic properties help you predict what comes next. So here's a periodic table. Is an early arrangement what it used to kind of look like before. Here are some patterns. I want you to pause the video here and take a look at these arrows. These are trends that we see on the periodic table. Let's look at the arrows that are pointing down first. Metallic properties increase from top to bottom. Valence electrons increase down a group and remain the same, right? So they have the same number of valence electrons, but more energy levels increasing from the top to the bottom. Metallic properties also increase from left to right. The atomic number increases from left to right, which is an observation we made in class the other day. Valence electrons increase across the period, also from left to right. And your atomic number increases from top to bottom. Take a good look at this. These trends are important to kind of have a good idea about. You can pause the video here and take a look at that. It's a little bit bigger. Read the periodic table information sheet. We're going to skip through this. This is another activity that that we can do that we did in class, color coding your periodic table. That is a good study aid for you tonight for your test tomorrow. Take a look at the way you've colored it and the way that like things are grouped together. Remember, groups are vertical, periods are horizontal. That's what this slide here is showing you. This line that was being formed there, let me go back to that slide. That line is separating the metalloids from the transition metals. I'm going to skip through this very quickly as we did this in class. All right, that's it. I hope you've enjoyed this and that you find it useful in reviewing your material for your test tomorrow. We'll see you tomorrow. Bye-bye.